So this is 9.2, B as in boy in trigonometry, still dealing with logarithmic functions here. And we are starting with example number 2. And it says to graph the logarithmic function. So we've got f of x for part A. And we're saying that equals the log with a base of 1/2 of x. So first of all, what we're going to do is we're going to write this in exponential form. We're going to replace that with a y. So 1/2 to the y power equals x. And then all we do is come up with x's and y's. So we're going to put in y values there. So let's put a 0 in there. And my x is 1. 1/2 to the 0 power is 1. We'll put a 1 in there, and that gives me a half. It'll give me a 2, and that gives me a 1/4. And give me a 6. And that gives me a 1/64. Alright, so when I graph this, it's going to give me 1, 0, 1/2, 1. So let's go 1, 0, 1/2, 1, 1/4, 2, and get closer and closer, but never actually hitting that. Now let's look at some negative values for the y value up here. So let's say that y is -1, -2, -3. Let's see what happens. So if we put -1 in there, it'd be 1/2 to the -1 power. That means it'll be 2. 1/2 to the -2 power would be 4. 1/2 to the -3 power would be 8, because remember that negative means that the 2 is in the wrong position, so it comes up, and it's 2 squared, and this 2 is in the wrong position, it comes up, and it's cubed, and that's where the 8 comes from. So then we continue on with the graphing, and we end up with a graph that looks like that. Okay. Part B is pretty much the exact same thing as what we just did. Get rid of all this junk here. It takes forever to erase it all. But anyway, we've got f of x equals log base 3 of x. I'm going to make that into a y. Base 3 of x, and then we're going to convert it to exponential form, and it looks like that. So then we just use our x and y like we just did on the last one, and we put a 0, we get a 1. Put a 1, we get a 3. Put a 2, we get a 9. Let's go the other way. Put a -1, and we get a 1/3. -2, we get a 1/9. Okay, so let's go ahead and graph that real quick. 2, 3, 4, 5, 6. Not real accurate because I did say I was going to do this quick. And I get a 1, 0. Then I get a 3, 1. Then I get a 9, 2. And then I get a 1/3 -1. So I get down here, and I get a graph that's going to look like that. Okay, and that would be part B. Okay, we look at example 3. We have f of x, and that equals the log with the base 2 of x minus 1. Alright, so a couple things to get here. This graph here is the same as this graph. The only difference is this -1 here means that it's translated 1 unit to the right. Okay, so it is this graph moved over 1 unit to the right. The vertical asymptote to this is 1 because it was shifted to the right 1 unit, so therefore this becomes a vertical asymptote instead of the y-axis, like we have stated in number 3 at the top of page 406. So in this one, the vertical asymptote would be y. Because we shifted it 1 over, our vertical asymptote moved from the y-axis over 1 to the number 1. So that's why that would be the vertical asymptote. The domain is normally 0 to infinity. So it's usually 0 to infinity. So that means if we have our axis here, our domain, well, it starts here at my vertical asymptote, which is normally y, and it goes to infinity. But with this minus y here, my vertical asymptote shifted over 1, so now my domain starts at 1. So your domain starts at your vertical asymptote and then goes to the right, and always to the right. Okay, so let's keep going here. Okay, so we don't have many points there, but we do have number 1 on top of page 406 tells me what a couple of my points are. It says that one of my points is 1 over a, negative 1. Another point is 1, 0. And another point is 2, my a value, and my y value then on that would be 1. So there's 3 points right there. But again, since everything was shifted 1 to the right, this ends up being 1 and 1/2, negative 1. Shift that over to the right 1. This gets shifted to the right 1, and that gets shifted to the right 1. So for f of x equals log base a of x, or base 2 of x is what we have up here, right here, it would look like that. But because we shifted everything to the right, those top 3 in black here, these turn into that. Everything shifted 1 to the right. Okay, so now I've got a red mess here. Let's see if I can get rid of some of this stuff so that I can draw my graph. Golly. Okay, so we're going to focus on these 3 points, but we need a few more. So we have our x and our y. Looking at that, let's change that to exponential form. So changing it to exponential form would be 2 to the y power equals x minus 1. Okay, so 2 to the y power equals x minus 1. And then I can just start putting numbers in for my x and my y value. In fact, what some people will do is they will write this as 2 to the y value plus 1 equals x. So then we can put a number in there for my y value. So let's put a 0 in there, and that becomes 1 plus 1. Put a 1 in there, and that becomes 2 plus 1. Put a 2 in there, and that becomes 4 plus 1. And you can start getting your graph then. So I've got a whole bunch of points here because I've got the 3 down there on the bottom that I was given in every one of these problems from top of page 406, number 1. So 1.5, negative 1, let's do that in red, and 2, 0, and 3, 1, and I already got a 2, 0, I already wrote 3, 1, so 1, 2, 3, 4, 5, 1, 2. So I end up with a graph that kind of looks like that, and I know it's not going to cross 1 because that's my domain, And so really I didn't even have to pay much attention to that shifting 1 to the right, except when I looked at the 3 point options for number 1, top of page 406. I had to shift my x piece all the way, over 1 in order to graph it, but that's really the only reason I needed that shift. And then I just pick some points and graph it, and it really wasn't any problem. So for the B portion of example 3, we have f of x equals log with a base 3 of x, and then we're taking 1 away from it. So it's a little bit different than example A. So we can write this then as y equals log base 3 of x minus 1, like that. And I'm going to write this as y plus 1 equals log 3 of x. And then I can go ahead and change it to exponential form, which I don't want to do that like that. And it ends up being 3 to the y plus 1 right there equals x. And then I can put in an x and a y and grab myself some points. Alright, so what do I know? I know that it is different than this one simply because I subtracted 1. Okay, and in the last one it had the x minus 1 here. In this one it has this here, and we're taking 1 away from it. And this minus 1 right in there means that we translated this whole graph 1 down. Okay, so what that means is my step 1 on top of page 406, where it says 1 over a negative 1 1 0 and a 1. Okay, we're going to replace the a with 3, and that negative 1, it says we're shifting it down 1, so it'll be a negative 2 now, and this will be 1 negative 1, and this a here is that number right there, and this gets shifted down 1, so that gets shifted to 3 0. Okay, so there's 3 points right there. Now we just take some x's and y's, put them in here to get some more points, and then go ahead and graph it. So again, all we used our negative 1 here was to find out that we shifted down, translated 1 unit down, so we change our y values here by 1. Now if we would have shifted left or right, we would have changed our x values that amount. And then we put a few more numbers in here, like maybe 3, so that we get 6 numbers, and we go ahead and graph that. So that is it for lesson 9.2b, and we'll start with properties of logarithms in the next video.